Alright, today we're going to be talking about scale drawings and models. We're also going to be using the butterfly method and proportions. So we have some vocabulary today. The first one, basically just what is a scale drawing or a model. I'm sure you've seen most of them before. It's used to represent an object that is either too large or too small. And for example, I'm sure you might have seen a blueprint or like model cars or model trains, anything that's a representation of something, but it's not the actual size. Now, what a scale is basically it's what the ratio is of the drawing or the model to the actual object. When you're writing the scale, you need to make sure that the drawing or the model comes first. I'll show you an example of that on the next slide. The next thing is the scale factor. It's basically when the drawing or the model and the actual object, whenever they have the same unit of measures. The scale factor is when they have the same unit of measures. So this we have is a blueprint. This is an example of a scale drawing because this is not the actual size of the building. I'm not exactly sure what type of building this is because it has like a dungeon in it. I'm not really sure what that's about. But the reason why I liked this is because down at the bottom left, it shows what the scale is. So this scale, it has two different places that they wrote it out and they typed it in a computer so that it would be legible. This says 1/8 of an inch is equal to 1 foot. So remember, the scale drawing goes first. So the 1/8 of an inch represents 1 foot. Same exact thing, an 1/8 of an inch is equal to 1 foot. Now if we talk about the scale factor, where the inches, where either they all have to be converted to inches or it all has to be converted to feet. With this, I converted a foot into inches, so instead of changing the 1/8 of an inch into feet, I changed the foot into inches. So 1/8 of an inch is equal to 12 inches. This is what the scale factor of this plan would be. Now we're going to try to determine the scale. This is an example for you. I need you to write this down. So we have a model dragonfly. It has the wing length of 4 centimeters. If the length of the actual wing is 6 centimeters, what is the scale of the model? So it's important when we set this up. Model should go on the top. In the numerator, we're going to set up a proportion. The actual length should go into the denominator. So let's underline the information that we know. We have the model is 4 centimeters and the actual wing length is 6 centimeters. So all we had to do is just input our information. The model, make sure it goes straight across. The actual, make sure it goes straight across. So we are trying to solve the scale of the model. Remember, the model always comes first before the actual length. So we're going to solve for x. Remember, what's the easiest way that we could do it? Remember, we could just set it up as the butterfly method. So 6 centimeters times 1 centimeters would be 6 times 4x. Remember, we need to get x by itself. So the opposite of multiplying by x is multiplying by 4 is to divide by 4. So divide by 4, those cross out, and x is equal to 1.5 centimeters, or 1 1/2 centimeters. So this is what would be our final answer. Our scale of the model is 1 centimeter is equal to 1 1/2 centimeters. This would actually be what our scale is. So now I want you to try. We have this example. I want you to pause the video, unpause the video when you're ready to see what I have done. Okay, so we have the pillars of the World War II Memorial in Washington, D.C. They are 17 feet tall. On a scale model, they are 5 inches tall. I want to know what is the scale of the model. So remember, I like to put the model up top and the actual on the bottom or in the denominator. If we are trying to solve for the model, let's look at the information that we are given. I want to figure out the model length, so the model is 5 inches tall. So the model is 5 inches. The actual length, they are 17 feet tall. So we have 1 inch, and then we are going to be trying to solve for x feet. So let's see here, remember, butterfly method, 17, and 5 times x will be 5x. Have to solve for x, so we're going to divide by 5. When we divide by 5, we find that x is equal to 3.4. Remember, or 3 4/10. This is in feet. It is always important to carry your units. So that's what x equal to. But I want to know what is the scale of the model. We have 1 inch. What does that feet equal to? So 1 inch is equal to 3 4/10 feet. This is what our scale of the model is. So now I'm wanting to find some actual measurements. We have an example. So I have the blueprint of a skateboard ramp, shows that the length is 11 4/10 inches. If the scale on the blueprint is 1 inch is equal to 6 feet, what is the length of the actual skateboard ramp? So remember, I like to set up proportions, model information on the top, actual information on the bottom. So let's look at the model information. Well, we're given a scale of 1 inch is equal to 6 feet. The inch, remember, goes with the model, so 1 inch is equal to 6 feet. What other information are we given? We are given 11 4/10 inches. That deals with the model. So we're going to just input the information. Remember, model, straight across in the numerator. So the model will be 11 4/10 inches. We are trying to find the length of the actual skateboard ramp. So I'm going to put that in for x. Again, remember, all you have to do is the butterfly method. So 6 times 11 4/10 is 68 4/10. That's equal to 1x, which is basically x is equal to 68 4/10 feet. Remember, we're talking about the actual measurements, so we're converting feet, and x is going to be equal to feet. So the actual length, x, is equal to 68 4/10 feet. That's the actual length of the skateboard ramp. So now what I want you to do, I want you to look through this example, and you're going to try to create your own scale drawing. What I want you to do, pause the video, unpause the video when you're ready to see what I've done. Okay, so we have Brian, who is painting a mural that measures 18 feet long and 12 feet tall. I want to make a scale drawing. And the scale that I'm going to use is the scale of 1/4 of an inch is equal to 3 feet. So I broke it out. the length is on one side and the height is on the other side. So remember the model information up on the top. I'm just going to convert this 1/4 into a decimal, just because decimals would be easier to work with when we're dealing with proportions. So this would be 25 hundredths of an inch. So the information, 25 hundredths of an inch, and that would be the actual length is 3 feet, and the actual length that we're dealing with is 18 feet. So I'm trying to figure out what's the size of the model that we're going to use. So with this, remember, butterfly method, so that's 3x. 18 times 25 hundredths is equal to 4.5, and divide by 3. So x is going to equal 1.5. Remember, we're dealing with inches. We're dealing with inches because the inches we're talking about the model. So this is inches. So x for this is going to be 1.5 inches. So the next one, so that's the length. Now we're going to talk about the height, or how tall they are. So remember, we do the exact same thing with the scale drawing, the model, and the actual length. And the height that we have is 12 feet. So that goes straight across on the, remember, actual straight across. We are solving for x. So remember the butterfly method, and that would be 3x. And we multiply these. We multiply 12 times 25 hundredths, and that is equal to 3. So when we solve it through, we have to divide by 3 on both sides. So x is equal to 1 inch. So if we do draw this out, it would be a length of 1.5 inches and the height of 1 inch. So that would be the scale drawing that you would have to draw. Time for a quick review. Remember, when we are setting up a proportion, the most important part when we're dealing with scale and units of measurement is we have to make sure that everything is lined up properly. This is why I like having all of the information from model up on the numerator, and this is why the information for like the actual height or the actual dimensions of something are in the denominator. So please take your time, ensure that everything lines up properly, and double check all of your work.